Hello, in this lecture we will find the size of angle X in two different methods. In the drawing we have quadrilateral SRPQ, and we know that SP is equal to SQ, so we will define SP as Y, and then SQ will be also equal to Y because they are equal to each other, and we also know that angle SRP, this angle is equal to 65 degrees, angle PRQ or QRP is equal to 50 degrees, and we want to find out the size of angle PSQ, that is actually defined as X. So we will start with the first method. We will do a construction. Actually, we will extend side QR by a straight line. And then from point X, we will draw perpendicular to the extended QR. So this angle is a right angle, it equals to 90 degrees. And the touching point between the perpendicular to the extended QR will be defined as N, and we will also draw perpendicular from point S to PR. Okay, we will draw perpendicular from point S to PR. So this angle will be equal to 90 degrees, is a right angle, and this angle will be also equal to 90 degrees. So we will find out the size of angle NRS, the size of this angle. We will define it as angle Z, and actually we know that QR is one side of quadrilateral SRPQ. Therefore QR is a straight line. Then we actually extended the straight line QR by a straight line. So QN will still be a straight line. So I'll write it down. QN is a straight line. And we have a rule number one. Rule number one states that the sum of the angles on one side of a straight line equals to 180 degrees. I will write it down. The sum of the angles on one side of a straight line equals to 180 degrees. So we can actually implement the rule number 1 in our drawing, because we know that QN is a straight line. So if we look on this side, on the bottom side of the straight line NQ or QN, we know that according to rule number 1, if you focus at point R, the sum of the angles must be 180 degrees. That is to say, angle Z plus 65 degrees plus 50 degrees must be equal to 180 degrees according to rule number 1. Okay, because we look only on the bottom side of the straight line NQ at point R, the sum of the angles must be equal to 180 degrees. That is to say, angle Z plus 65 degrees plus 50 degrees must be equal to 180 degrees. So we will subtract 50 degrees from this equality, and we will get that angle Z plus 65 degrees equals to 180 degrees minus 50 degrees is 130 degrees. Then we will subtract 65 degrees from this equality, and we will get that angle Z equals to 130 degrees minus 65 degrees is 65 degrees. So we found out that the size of angle Z, this angle, is actually equals to 65 degrees. So we write here that this angle equals to 65 degrees. Okay. In the next step, we will prove that the right triangle, first of all, we will define the touching point between the perpendicular from point S to PR as point M. Okay? And we'll prove that the right triangle, triangle SMR, the right triangle, triangle SMR, is equal to, is congruent to the right green, to the right blue triangle, triangle SNR. Again, we will prove that the green triangle congruent to the blue triangle. Okay, so actually we will focus on the right triangle, to the green triangle, on the green triangle, triangle SMR. And the blue triangle, triangle SNR. And we will prove that the green triangle, triangle SMR is congruent to the blue triangle, triangle SNR. Okay. So first of all, we have a common side. SR is a common side. it belongs to both triangles, so we can write down that SR equals to SR. It is a common side that belongs to both triangles. Again, SR equals to SR is a common side that belongs to both triangles. And actually we have both in the green triangle and the blue triangles two angles that are equal to each other. These two angles are both equal to theta, to 90 degrees, and those two angles are both equal to 65 degrees. And we know that the sum of the angles in any triangle is equal to 180 degrees. So because of the fact that we know the sizes of two angles of the triangle, then the size of the third angle must be equal to 180 degrees minus the sum of the two other angles. So the size of this angle MSR, will be the same as the size of this angle NSR, because it will be 180 degrees minus the sum of those two angles, minus 90 degrees plus 65 degrees. 90 degrees plus 65 degrees is actually 155 degrees. So the size of this angle and this angle will be equal to 180 degrees minus the sum of those two angles, that is actually 155 degrees. That is to say, it equals to 25 degrees. So we actually found out that this angle equals to 25 degrees, and this angle also equals to 25 degrees, and they are equal to each other, of course. So actually we have angle MSR of the green triangle that equals to angle NSR of the blue triangle, and both angles are equal to 25 degrees. We also have those two angles that they are both equal to each other. They are right angles, they are equal to 90 degrees, so angle SMR in the green triangle is equal to angle NSR to angle SNR in the blue triangle, and both those two angles are right angles, they are equal to 90 degrees. And the third angle, the first pair of angles are also equal to each other, they are both equal to 65 degrees. So angle MRS in the green triangle is equal to angle NRS, this angle in the blue triangle, and both those two angles are equal to 65 degrees. So we actually found out that all three angles of the green triangle are correspondingly equal to all three angles of the blue triangle. Actually, therefore, we can conclude that the green triangle SMR, the green right triangle SMR, is congruent. This is the sign of congruent to the blue triangle SNR, according to angle side angle rule. Angle side angle rule. So what is angle side angle rule? If you prove that two sides of a triangle, of one triangle, two sides, and if you prove that two angles and the side that attach to those two angles in one triangle are correspondingly equal to two angles, and the side that attach to those two angles in the other triangle, then you proved that those two triangles can go into each other according to angle side angle rule. And actually we proved more than we need to prove. We proved that those two angles and side SR are correspondingly equal to those two angles and side SR of the blue triangle. Therefore, we actually proved also that those two angles are also equal to each other. So we actually proved more than what is needed to prove that those two triangles can go into each other according to angle side angle rule. So from the fact that the green triangle is congruent to the blue triangle, we can conclude that side SM of the green triangle is equal to side SN of the blue triangle. So I'm writing down side SM of the green triangle is equal to side SN of the blue triangle, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other. Therefore, the corresponding sides, those two corresponding sides, SM and SN, are equal to each other as corresponding sides in congruent triangles. Okay, so SM equals to SN. So, in the next step, we will focus on two other right triangles. We will focus on the right triangle SMP. In the right triangle SNQ. And we will actually prove that those two triangles can go into each other. The triangle SMP can go into triangle SNQ. So, first of all, we know that SM equals to SN. We just right now proved that SM equals to SN. SM, the side of triangle SMP, is equal to SN, the side of triangle SNQ. So SM equals to SN. And we also know that SP equals to SQ and it equals to Y according to our definition. Those two sides are equal to each other according to what is given us in the question, and we define those two sides as Y. So we can write down that SP is equal to SQ and both sides are equal to Y according to our definition. SP equals to SQ equals to Y according to our definition, and we will prove now that PM equals to NQ. Again, we will prove that side PM of triangle SMP is equal to side NQ of triangle SNQ. PM equals to NQ. So that is what we need to prove, that PM equals to NQ. Actually, both triangles are right triangles, so we can implement the Pythagorean theorem in both right triangles. So we will use the Pythagorean theorem in order to calculate the value of PM and the value of NQ, and we will see that those two sides are equal to each other. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so if we implement the Pythagorean theorem in the right triangle, triangle SNP, we will get that SM square plus PM square equals to PS square. SM square plus PM square is equal to SP square. Here we will subtract SM square from this equality, and we will get that PM square is equal to SP square minus SM square. So here we will take a root out of this equality, and we will get that PM equals to the root of SP square minus SM square. So we will repeat on the same process on the right triangle, triangle SNQ. So on the right triangle, triangle SNQ, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, SN square plus NQ square will be equal to SQ square. Again, SN square plus NQ square will be equal to SQ square. I will repeat again, in the right triangle, triangle SNQ, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, SN square plus NQ square equals to SQ square. We will subtract from this equality SN square, and we will get that NQ square equals to SQ square minus SN square. Here we'll take a root out of this equality, and we will get that NQ equals to the root of SQ square minus SN square. Okay, But we have already found out that PM equals to the root of SP square minus SM square. Actually, those two expressions are equal to each other. Therefore, from the fact that we prove that those two expressions are equal to each other, we will conclude that those two expressions are also equal to each other, that is to say, NQ equals to PM. So, we will write together those two expressions in one row. So NQ actually equals to the root of SQ square minus SN square. And PM equals to the root of SP square minus SM square. So now we will prove that those two expressions are equal to each other, and therefore we will conclude from it that NQ equals to PM. First of all, we know that SQ equals to SP. SQ equals to SP. SQ equals to SP according to what is given as the question. And we also know that we have already proved that Sn equals to Sm. Here Sn equals to Sm according to what we have already proved. So actually those two expressions are equal to each other. And this expression is actually NQ that equals to this expression that is actually PM. So we proved that NQ equals to PM. So we actually proved that all three sides of this right triangle are correspondingly equal to all three sides of this right triangle. Therefore, we actually proved that the right triangle SMP, this right triangle, is congruent to this right triangle SNQ. Again, the right triangle SMP is congruent. This is the sign of congruent. Is congruent to the right triangle SNQ according to side rule. So side rule is that if you prove that all sides of one triangle are correspondingly equal to all sides of the other triangle, then you proved that those two triangles can go into each other according to side rule. Okay? So from the fact that those two right triangles can go into each other, we will conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles will be also equal to each other. That is to say, angle SPM is equal to angle SQN. Angle SPM is equal to angle SQN. According to the rule that corresponding angles in congruent angles are equal to each other. And if we define this angle as theta, then this angle will be also equal to theta, because they are equal to each other. Angle SPM equals to angle SQN, and both angles are equal to theta according to our definition. So in the next step I will present to you the new rule number 2, and we will implement rule number 2 in our drawing. So actually, rule number 2 states that if a line segment subtends two equal angles, on the same side, then the quadrilateral is inscribed by a circle, the quadrilateral and the 4 points lie on that circle. So I will read rule number 2 again. Rule number 2 says that if a line segment subtends two equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. So we actually can implement rule number 2 in our drawing, because in our drawing we have here two equal angles, they are both equal to theta, and they are both subtend on the same line segment SR. This angle theta subtend on the line segment SR, and this angle theta also subtend on the same line segment SR. Therefore, according to rule number 2, the quadrilateral SRPQ, this quadrilateral SRPQ is inscribed by a circle, and the 4 points S, R, P, and Q lie on that circle. So actually, we will repeat on rule number 1. We have here two equal angles, they are both equal to theta, and they both subtend on the same segment line SR, exactly as we can see from this drawing. Therefore, according to rule number 2, this quadrilateral in the red color, quadrilateral SRPQ is inscribed by the black circle, and the 4 points S, R, P, and Q lie on this black circle, so you can see from the drawing. So this is the implementation of rule number 2 in our drawing. Okay, so we also have rule number 3. Rule number 3 states that peripheral angles subtending on the same chord are equal to each other. So I'll read rule number 3 again. Rule number 3 states that peripheral angles subtending on the same chord are equal to each other. And again, we can implement rule number 3 in our drawing, because in our drawing we have two peripheral angles. X is peripheral angles, or angle PSQ that equals to X is a peripheral angle that subtends on chord PQ, and we have also angle PRQ, this angle that equals to 50 degrees that subtends on the same chord PQ. Therefore, according to rule number 3, peripheral angles subtending on the same chord are equal to each other. That is to say, those two peripheral angles that subtend on the same chord PQ are equal to each other. That is to say, X equals to 50 degrees. Okay, so we found out that angle X equals to 50 degrees. Oh, I write it here. Angle X equals to 50 degrees according to rule number 3. I'll repeat again. Those two peripheral angles subtend on the same chord PQ, therefore according to rule number 3 they are equal to each other. That is to say, X equals to 50 degrees. Okay, so we actually finished with the first method. In the next step I will present to you a second method. We will find out the size of angle X according to a second method. So actually in the second method we will do another construction. We will extend side SR of quadrilateral SRPQ by a straight line. So we extended side SR of quadrilateral SRPQ by a straight line. Then from point Q we will raise perpendicular to the extended SR. So this angle equals to 90 degrees because it is a perpendicular to the extended SR, and we will define the touching point between the perpendicular to the extended SR as point M. This point is point M. In the next step, we will extend the perpendicular QM in such a way that it will be equal to, again we will extend the perpendicular QM in such a way that Q dash M, this side, will be equal to QM. We extended QM in such a way that Q dash M will be equal to QM. Okay? Then we will join together points R and Q dash by a straight line. Join together points R and Q dash by a straight line, and we will also join together points S and Q dash by a straight line. I'll repeat again. We join together points S and Q dash by a straight line. So we know that SR is one side of quadrilateral SRPQ. So SR as a side of perpendicular must be a straight line. Then we extended the straight line SR by a straight line. So SM will be still a straight line. So write it down that SM is a straight line. SM is a straight line. This line segment SM is a straight line, and we have rule number 1 that says that the sum of the angles on one side of a straight line equals to 180 degrees. So if we look from the bottom side of the straight line SM at point R, the sum of the angles must be equal to 180 degrees. Okay, so on the bottom side of the straight line SM at point R, the sum of the angles must be equal to 180 degrees. So 65 degrees plus 50 degrees plus the size of this angle that we will define as angle Z. So the sum of those two angles must be equal to 180 degrees according to rule number 1. Again, the sum of the angles on the lower side of the straight line SM at point R must be equal to 180 degrees according to rule number 1. That is to say 65 degrees plus 50 degrees plus the size of angle Z must be equal to 180 degrees or 180 degrees. So we will subtract 50 degrees from this equality, and we will get that 65 degrees plus angle Z equals to 180 degrees minus 50 degrees is 130 degrees. we will subtract from this equality 65 degrees, and we will get that angle Z equals to 130 degrees minus 65 degrees is 65 degrees. So we found out that angle Z equals to 65 degrees. Okay, so we can write here that angle Z equals to 65 degrees. In the same way, we will find out the size of this angle, angle Q dash MR. Actually, QM is perpendicular to the extended SR, so as perpendicular, QM must be a straight line, okay? And then we extended the straight line QM by a straight line, so Q dash will be still a straight line. Q dash is a straight line. Q dash is a straight line. Again, line segment Q dash is a straight line. So if we look on from this side of the straight line Q dash or Q dash Q at point M, the sum of the angles must be equal to 180 degrees according to rule number 1. That is to say 90 degrees plus the size of this angle that we will define as angle L must be equal to 180 degrees according to rule number 1. So I will write it down. 90 degrees plus the size of angle L must be equal to 180 degrees according to rule number 1. Okay, so here we will subtract from this equality 90 degrees, and we will get that angle L equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle L is a right angle, it equals to 90 degrees. So we write it here that angle L is a right angle. So we have at point M two right angles. Okay, in the next step we will actually focus on the right triangle QMR and the right triangle Q dash MR, and we will prove that those two right angles can go into each other. Okay, so we will focus on the right triangle QMR, right small triangle QMR. And the right small triangle Q dash MR. I will repeat again, we will prove that the right small triangle QMR is congruent to the right small triangle Q dash MR. Okay? So first of all, we know that QM equals to Q dash M. Okay, QM equals to Q dash M according to our construction. QM equals to Q dash M according to our construction. QM equals to Q dash M, that is according to our construction. Before I continue, we will define SP as Y, and then because of the fact that SP equals to SQ, then SQ will be also equal to Y. So it is equals to Y, SP equals to SQ according to what is given us in the question, it equals to y according to our definition. Okay, so we will continue to prove that those two right small triangles can go into each other. So we also know that those two angles are equal to each other. They are both right angles. They are equal to 90 degrees. So angle QMR in triangle QMR is equal to angle Q decim R in triangle Q decim R. Q des and both angles are equal to 90 degrees. Angle QMR is equals to angle Q decim R, and both angles are equal to 90 degrees. And we also have here common side RM equals to RM is a common side that belongs to both triangles. RM equals to RM is a common side that belongs to both triangles. RM equals to RM is a common side. So we actually found, proved that the right small triangle QMR can go into the right small triangle Q decim R according to side angle side rule. So I write it down. We have one side angle and the other two sides. Okay. So those two triangles can go into each other according to side angle side rule. I write it down. Triangle, the small right triangle QMR can go into the small right triangle Q decim R according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove the two sides and the angle between them in one triangle are correspondingly equal to two sides and the angle between them in the other triangle, then you proved actually that those two triangles can go into each other according to side angle side rule. And here in our drawing we proved that those two sides and the angle between them in triangle Q decim R are correspondingly equal to those two sides and the angle between them in triangle QMR. Therefore, we proved that those two right triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. And we know that this angle equals to 65 degrees, so this angle will be also equal to 65 degrees because of the fact that those two angles are equal to each other. So I write it down that angle QRM is equal to angle Q decim and both angles are equal to 65 degrees. Okay, angle QRM is equal to angle Q decim. Angle QRM is equal to angle Q decim, and both angles are equal to 65 degrees. The second thing that we will conclude from the fact that those two right small triangles can go into each other, that side arc Q of triangle MQR is equal to side arc Q des of triangle Q decim R. According to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding sides will be equal to each other. So I will write it down that side QR for triangle MQR is equal to side Q dash R of triangle Q dash MR. Okay, side QR is equal to side Q dash MR according to the rule that corresponding sides and congruent triangles are equal to each other. Okay, so in the next step we will focus on the right big triangle, triangle QMS, and on the right big triangle, triangle Q dash MS. Those two big right triangles, and we will prove that those two big right triangles are equal, congruent to each other. Okay, so I will write it down. We will prove that the right big triangle, triangle QMS, is congruent to the right big triangle, triangle Q dash MS. I will repeat again. We will prove that the right big triangle, triangle QMS, is congruent to the right big triangle, triangle Q dash MS. First of all, we know that QM or MQ is equal to Q dash M according to our construction. So QM is equal to Q dash M according to our construction. QM equals to Q dash M according to our construction. We also know that those two angles are equal to each other, they are both equal to 90 degrees. So angle QMS is equal to angle Q dash MS, and both angles are equal to 90 degrees. Angle QMS is equal to angle Q dash MS, and both angles are equal to 90 degrees. And we also have a right side SM is a common, we have a common side, SM is a common side, it belongs to both triangles. So we can write down that SM equals to SM as a common side that belongs to both triangles. Again, SM equals to SM as a common side. So we actually proved that the right big triangle, triangle QMS, is congruent to the right big triangle, triangle Q dash MS, according to side, angle, side rule. We have side, angle, and side. Okay, so I will write it down. We actually proved that the right big triangle, triangle QMS, is congruent to the right big triangle, triangle Q dash MS, according to side, angle, side rule. So I will repeat shortly that what is side, angle, side rule. We actually proved that those two sides and the angle between them on the right big triangle, triangle Q dash MS, are corresponding equal to those two sides and the angle between them on the right big triangle, triangle QMS. Therefore, we proved that those two right big triangles congruent to each other according to side, angle, side rule. And from the fact that those two triangles congruent to each other, we will conclude that SQ equals to SQ dash, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two right big triangles congruent to each other. Therefore, the two corresponding sides, that is to say SQ SQ and SQ dash will be equal to each other. So I will write it down. Actually, SQ is equal to SQ dash, but we know that SQ equals to Y, so SQ dash will be also equal to Y. Okay, so here SQ dash will be also equal to Y, so we actually found out that SQ is equals to SQ dash and it equals to Y according to our definition. And in the next step we will prove that triangles SRQ and triangle SRQ dash can go into each other. I will repeat again. We will prove that triangles SRQ and triangle SRQ dash can go into each other. First of all, we have already proved that RQ equals to RQ dash. RQ equals to RQ dash. We have already proved that RQ equals to RQ dash. We just right now proved that SQ equals to SQ dash. Both of them are equal to Y. SQ equals to SQ dash. And both of them are equal to Y according to our definition. And okay, so SQ equals to SQ dash, and they are both equal to Y according to our definition. And we have here a common side. SR is a common side, it belongs to both triangles, so we can write down that SR equals to SR as a common side. SR equals to SR as a common side. Again, SR equals to SR as a common side. So we actually proved that triangle SRQ is can go into triangle SRQ dash according to side rule. Side rule. Okay. And again, what is side rule? Side rule is that if you prove that all the sides of one triangle are corresponding equal to all the sides of the other triangle, then you proved that those two triangles can go into each other according to side rule. And we proved that all the sides of triangle SRQ are corresponding equal to all the sides of triangle SRQ dash. Therefore, we proved that those two triangles can go into each other according to side rule. So I will write it down. Triangle SRQ can go into triangle SRQ dash according to side rule. Again, triangle SRQ can go into triangle SRQ dash according to side rule. So from the fact that those two triangles can go into each other, we will conclude that those two angles are equal to each other. So this angle is equal to this angle. I will write it down. Angle SQR. Angle SQR is equal to angle SQ dash R. Again, angle SQR is equal to angle SQ dash R according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding angles, those two corresponding angles will be equal to each other. Okay? So, and if we define this angle as theta, this angle will be also equal to theta because of the fact that those two angles are equal to each other. So, we actually prove that angle SQR equals to angle SQDSR, and both angles are equal to theta according to our definition. So in the next step, we will prove that line segment PQ dash, this long line segment PQ dash is a straight line. Okay? PQ dash, we will prove that is a straight line. Actually, we will prove that angle PRQ dash, if you look from the bottom side of angle PRQ dash, it equals to 180 degrees, and therefore line segment PRQ dash is a straight line, and therefore PQ dash must be also a straight line. So what is the size of angle PRQ dash if you look from the bottom side of it? The size of angle PRQ dash is actually 50 degrees. We look from the bottom side of angle PRQ dash. It equals to 50 degrees plus 65 degrees plus 65 degrees. Okay, so 65 degrees plus 65 degrees is 130 degrees, and 130 degrees plus 50 degrees is 180 degrees. So we proved that angle PRQ dash equals to 180 degrees. So if angle PRQ dash is equal to 180 degrees, it must be a straight line. Any angle that equals to 180 degrees is a straight line. Therefore, actually, line segment PRQ dash is a straight line. So if line segment PRQ dash is a straight line, then PQ dash is also a straight line, okay? Therefore, PQ dash is a straight line. PQ dash is a straight line. And if line segment PQ dash is a straight line, then the shape PSQ dash is a triangle. Okay, PSQ dash is a triangle. Okay, the shape PSQ dash is a triangle. So actually, in triangle PSQ dash, we have two angles, two sides that are equal to each other. PS equals to SQ dash equals to Y according to our definition. So PS equals to SQ dash, and it equals to Y according to our definition. So I repeat again, in triangle PSQ dash, PS equals to SQ dash equals to Y according to our definition. So we have another rule. The rule states that in front of equal sides in the triangle, there are equal angles. So in front of these two equal sides in triangle PSQ, we will have equal angles. Those two angles are located in front the equal sides, those two equal sides. Okay, therefore they are equal to each other, but we know that this angle equals to theta, so this angle also must be equal to theta. Okay, so from now on we will continue according to method 1, according to the first method. We have here two equal angles, both of those two angles are equal to theta, as you can see from the drawing. And both those two angles subtend on the same segment line SR. Therefore, according to rule number 1, the quadrilateral SRPQ, this quadrilateral, is inscribed by a circle. Again, the quadrilateral SRPQ is inscribed by a circle, and the 4 points SR, P, and Q lie on this circle, on that circle. This is according to rule number 1 that I mentioned in the first method. I will repeat on rule number 2. Here we have two equal angles, they are both equal to theta, and they are both subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by the black circle, and the 4 points SR, P, and Q lie on this black circle. Okay? I'll repeat again, those two angles that are equal to each other, they are both equal to theta, subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ, this quadrilateral is inscribed by the black circle, and the 4 points SR, P, and Q lie on this black circle, as you can see from the drawing. And we have also rule number 3. Rule number 3 states that peripheral angles subtending on the same chord are equal to each other. So we have here two peripheral angles. Angle X is peripheral angle that subtend on chord PQ, and angle PRQ that equals to 50 degrees also subtend on the same chord PQ. Therefore, according to rule number 3, they are equal to each other. That is to say, angle X equals to 50 degrees. So we found out that angle X equals to 50 degrees according to rule number 3 that we mentioned already in the first method. So we found out that angle X equals to 50 degrees according to rule number 3. I will repeat again. We have those two peripheral angles that subtend on the same chord PQ, therefore they are equal to each other. That is to say, X equals to 50 degrees according to rule number 3. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the size of angle X, and we found out the size of angle X in two different methods. In the first method, we did a construction we extended side QR of quadrilateral SRPQ by a straight line, and then from point S we draw perpendicular to the extended SR. The touching point between the perpendicular to the extended SR is at point N, so this angle is a right angle, it equals to 90 degrees. Then we draw another perpendicular from point S to PR, and we define the touching point between the perpendicular to PR as point M. This angle is 90 degrees and this angle is 90 degrees because SM is perpendicular to PR. Okay, so then we calculated the size of this angle according to rule number 1 that states that the sum of the angles on one side of a straight line equals to 180 degrees. So actually QR is one side of quadrilateral SRPQ, therefore it must be a straight line, and we extended the straight line QR by a straight line, so QN will still be a straight line. So if we look from this side of the straight line QN at point R, the sum of the angles must be equal to 180 degrees according to rule number 1. That is to say, this angle is defined as Z, so angle Z plus 65 degrees plus 50 degrees must be equal to 180 degrees according to rule number 1. We subtracted 50 degrees from this equality, and we got that Z plus 65 degrees equals to 180 degrees minus 50 degrees is 130 degrees. We subtracted 65 degrees from this equality, and we got that angle Z equals to 65 degrees. So we found out that this angle equals to 65 degrees. Then we proved that the green triangle is congruent to the blue triangle. Both triangles are right triangles. First of all, we know that SR is a common side. It belongs both to the green triangle and also to the blue triangle. And we have in both triangles two angles, that one of them is 90 degrees and the other one is 65 degrees. Therefore, the third angle must be equal to 25 degrees in order to complete the sum of the angles in the triangle to 180 degrees. So we actually proved that three sides, all the sides of the green triangle are correspondingly equal to all the sides of the blue triangle, and we also have a common side SR. Therefore, we actually proved that those two triangles can go into each other according to angle side angle rule. We have one side that is a common side and the two angles that attach to SR that in the green triangle that correspondingly equal to the two angles and to SR in the blue triangle. Therefore, we proved that those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we can conclude that SM equals to SN according to the rule that corresponding sides and congruent triangles are equal to each other. So SM equals to SN, and then we focused on triangle SNP, a right triangle, and the right triangle SNQ, and we proved that those two right triangles can go into each other. First of all, we just right now proved that SM equals to SN. Then we know that SP equals to SQ, SP equals to SQ according to what is given us in the question, and we define both sides as Y. So SP equals to SQ equals to Y, and we proved that PM equals to NQ, because we have here two right triangles. So what is the size of PM? According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Therefore, actually, SM square plus PM square equals to SP square. SM square plus PM square equals to SP square. So we subtracted SM square from this equality, and we got that PM square equals to SP square minus SM square. We took a root out of this equality, and we got that PM equals to the root of SP square minus SM square. And then we repeated on the same process on the right triangle, triangle SNQ. According to the Pythagorean theorem, SN square plus NQ square will be equal to SQ square. SN square plus NQ square equals to SQ square. We subtracted SN square from this equality, and we got that NQ square equals to NQ square plus minus N square minus SN square. We took a root out of this equality, we got that NQ equals to the root of SQ square minus SN square. So we found out the value of NQ, and we already found out that PM equals to the root of SP square minus SM square. And actually those two expressions are equal to each other. That is to say, NQ equals to PM. Why those two expressions are equal to each other? Because here we presented them together. As you can see, SQ equals to SP according to what is given us in the question, and we have already proved that SN equals to SM. SN equals to SM according to what we have already proved. So we proved that those two expressions are equal to each other. This expression is actually NQ, and this expression is actually PM. So we proved that NQ equals to PM. Okay, so we actually proved that all the sides of the right triangle SMP are corresponding equal to all the sides of triangle SNQ. Therefore, we proved that the two triangles, triangle SMP is congruent to triangle SNQ according to side rule. Okay, so from the fact that those two triangles congruent to each other, we will conclude that those two angles are equal to each other, and if one angle equals to theta, then the other angle must be also equal to theta because of the fact that they are equal to each other. Okay, so angle SPM equals to angle SQN, and both of them are equal to theta according to our definition. Then I presented to you rule number 2 that states that if a line segment subtends two equal angles of the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. So we have here two angles that are equal to each other, both of them are equal to theta, and they subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by a circle, and the 4 points SR, P, and Q lie on that circle. Okay? I repeat again, those two angles that are equal to each other subtend on the same chord called SR. Therefore, according to rule number 1, the quadrilateral SRPQ is inscribed by the black circle, and the 4 points SR, P, and Q lie on this black circle. This is the implementation of rule number 2 in our drawing. And then we have also rule number 3 that states that peripheral angles subtending on the same chord are equal to each other. So we have here two peripheral angles, X and PRQ, that equals to 50 degrees, that subtend on the same chord called PQ. Therefore, they are equal to each other. That is to say, X equals to 50 degrees. So we finished with the first method, and then we found out the size of angle X according to the second method. In the second method, we did another construction. Actually, we extended SR by a straight line, and then from point Q, we drew perpendicular to the extended SR. We defined the touching point between the perpendicular to the extended SR as point M, and then we extended the perpendicular QM in such a way that Q dash M will be equal to QM. So Q dash M equals to QM according to our construction. Then we found out the size of this angle according to rule number 1 that states that the sum of the angle on one side of the straight line is equal to 180 degrees, and SR is one side of quadrilateral SRPQ, therefore it must be a straight line, and we extended the straight line SR by a straight line, so SM will be still a straight line, and we know that the sum of the angle on one side of a straight line is equal to 180 degrees. So if we look on the bottom side of the straight line SM, the sum of the angles must be equal to 180 degrees, that is to say 65 degrees plus 50 degrees plus this angle that we defined as angle Z must be equal to 180 degrees. Okay? 65 degrees plus 50 degrees plus the size of angle Z must be equal to 180 degrees. So it is one equation with one variable. So we found out that angle Z equals to 65 degrees. Then we found out also, we actually know that QM is perpendicular to the extended SR, therefore it must be a straight line, and we extended the straight line QN by a straight line, so Q must be also a straight line. And if we look from this side of the straight line Q at point M, the sum of the angles must be equal to 180 degrees. That is to say 90 degrees plus this angle that we defined as L must be equal to 180 degrees. 90 degrees plus angle L must be equal to 180 degrees. We subtracted 90 degrees from this equality and we found out that angle L is a right angle. This angle is a right angle, so at point M we have two right angles. Then we proved that those two right angles can go into each other. First of all, we know that QM equals to Q dash M according to our construction. Those two angles are equal to 90 degrees. And we have a common side. RM is a common side, it belongs to both triangles. So we actually proved that those two triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. And this angle equals to 65 degrees, so this angle must be also equal to 65 degrees because of the fact that those two angles are equal to each other. And we also concluded that RQ equals to RQ dash according to the rule that corresponding sides in congruent triangles are equal to each other. Then, so QR equals to Q dash R. Then we proved that the two big right triangles can go into each other. Triangle QMS, we proved that it is congruent to the right triangle Q dash MS. First of all, we know that QM equals to Q dash M. According to our construction, we have those two angles that are equal to each other. They are both equal to 90 degrees, and we have a common side SM that belongs to both triangles, so SM equals to SM. So we actually proved that those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we concluded that SQ equals to SQ dash. And SQ equals to Y, so SQ dash will be also equal to Y. Okay, and the next step we proved the triangle SRQ is congruent to triangle SRQ dash. Why? Because we have RQ that equals to RQ dash. We have already proved that those two sides are equal to each other, and we also know that SQ equals to SQ dash according to what we have already proved, and we have a common side SR. So SR equals to SR is a common side, so we proved that those two triangles can go into each other according to side rule. So from the fact that those two triangles can go into each other, we will conclude that those two angles are equal to each other, and if one angle is equal to theta, then the other angle must be also equal to theta. Then we proved that PQ dash is a straight line. Why PQ dash is a straight line? Because of the fact that angle PRQ dash is angle that equals to 180 degrees. If we look from the bottom side of angle PRQ dash, it equals to 180 degrees. 50 degrees plus 65 degrees plus 65 degrees is equal to 180 degrees. That is to say angle PRQ equals to 180 degrees, and any angle that equals to 180 degrees, it is a straight line. So angle PRQ dash is a straight line, line segment PRQ dash is a straight line, therefore line segment PQ dash is also a straight line. And because of the fact that line segment PQ dash is a straight line, then then the shape PSQ dash is a triangle. And in the shape PSQ dash, we know that PS equals to SQ dash, and we have the rule that in front of equal sides in the triangle there are equal angles. so those two angles that are located in front to equal sides, in front of those two equal sides, they will be equal to each other. And we know that this angle is theta, so this angle must be also equal to theta because of the fact that those two angles are equal to each other. So we have, so this angle will be also equal to theta. So from now on we continue to, according to method 1. I presented to you the rule number 2 that states that if you have a segment line that subtends two equal angles on the same side, then the quadrilateral SRPQ is inscribed by a circle, and the 4 points SRP and Q lie on that circle. Okay, and so actually, according to rule number 2, because of the fact that those two equal angles subtend on the same segment line SR, the quadrilateral SRPQ subtend on the black circle, and the 4 points SRP and Q lie on this black circle. And we have also rule number 3 that states that peripheral angles subtending on the same chord are equal to each other. And we have those two peripheral angles, angle X and angle PRQ, that equals to 50 degrees, that they are both subtending on the same segment line PQ, therefore they are equal to each other. That is to say, angle X equals to 50 degrees according to rule number 3, because of the fact that those two peripheral angles, they are both subtending on the same chord called PQ, therefore they are equal to each other. That is to say, angle X equals to 50 degrees. Okay? We proved in both methods that the size of angle X is equal to 50 degrees. Okay, thank you very much.